Hi everybody, welcome back. Sorry I don't have an intro page for you, but I tried to make it shorter. But today we're talking about multi-step equations that have very special kind of answers. Okay, so a multi-step equation can have three possible answers. One solution, it can have no solutions, and it can have infinite solutions. One solution stuff you guys have already dealt with. No solution means that there's no value for that variable that would ever make the equation true. Okay? And infinite solutions means that it doesn't matter what the value is, it will always be true no matter what. So you can put anything in for the variable. Alright, so let's look at some of these examples and we can see what they look like. I'm going to keep this in the corner because I want to see how long this video takes. And I'm hoping that if I see a bigger number, I will go faster and try to make it as short as possible. So, you guys can ignore this stuff. Alright, so example 1, solve the following equation. Well, that's easy. We're just doing the same 4 steps. Distribute, nothing to distribute. Combine, we do have a 5p and a 3p to combine, so we make that 8p. Now I need all our variables on one side and our constants on the other. So I'm going to move this p first, and sorry I'm writing it horizontally. It means same thing as if you were writing it underneath the p, but... So the p minus p will cancel out, leaving me with just negative 1, and the 8p minus p will leave me with 7p. So I got that. Now I'm going to go ahead and add 8 to both sides, and that's going to give me a 7 on this side and a 7p on the other side, right here. Now I go ahead and divide it by 7. I get 1 equals p. Stuff that you guys have already done before. Okay? Now, SBN stands for set builder notation. That's just my shorthand for it. So, to write this in set builder notation, remember, it's just the curly brace, your variable, a line, and then what your answer was. So this basically just says what all the possible answers are. So now that we can have more than one solution, it's really helpful. And it says it's just the group or the set of all p's, possible p's, such that p equals 1. So this one we only have 1, but we'll have different rules in here, okay? So let's look at example 2. So again, just solving the equation is not the hard part. It's identifying what kind of answer we have. Is it one solution, no solution, or infinite? So let's look at this one. So I got to distribute first the negative 4. Did that. So I get negative 4 plus 24, because negative 4 times negative 6 gives me a positive 24. I'm going to go ahead and subtract this 24a from both sides. So here I get 24a minus 24a cancels out, 24a minus 24a cancels out. So I'm left with negative 22 equals negative 4. So as you can see, I have no more a's, and I'm left with a false statement. That's not true. Negative 22 does not equal negative 4. So when this happens, and I get all my variables are like canceled out and gone, and I'm not left with a true statement, what happens is that means that there's no solution, no possibility for A that will make this a true statement, okay? Doesn't mean A equals 0. That does not happen. It means that nothing will work, not even 0 will work, okay? So, when that happens, that means I have no solution, okay? And we write that in set builder notation by just saying the variable such that the variable is not an element of, that's what the symbol means. When it has the E stands for an element, and the line through it means it's not an element. And this double R stands for the real number system. And those are the numbers that we're dealing with in algebra, are the real number system. So nothing in the real number system will work, so we say that it's not an element of the real number system. That's how we write it in set builder notation. Okay? Now remember, at any point, if you have a question, please write it down or put a star next to it. I'll be happy to answer it in class. For some reason, this is showing up. Oh well. Alright, here, again, we're just solving the equation, so I distribute the negative 2 first. I get negative 2x minus 4 equals 4x minus 4 minus 2x. Combine my like terms of 4x and negative 2x. I know negative 2x minus 4 equals 2x minus 4. I'm going to subtract 2x, or, yeah, I'm going to subtract 2x from both sides. I don't know why I subtracted 2x. Oh. So now I have negative 2x minus 2x. That's going to combine to be negative 4x. 2x minus 2x combined to be 0. So I'm left with negative 4x minus 4 equals negative 4. Now I'm going to add 4 to both sides. Okay? The negative 4 plus 4 cancels out, so I get, what did I get? Where did it go? Ooh. Okay, so now I get negative 4x equals 0. Divide by negative 4, I get x equals 0 as my final answer. That is not the same thing as no solution. Okay, I want you to be very careful. So to write that in simple notation, it means it's every x as long as x equals 0. That's what that means. Here's a what-if situation for you. I want you to write this down, if I can find it. What if negative 2x minus 4 equals negative 2x minus 4? Well, then I would add 2x to both sides. All the x's would be canceled out, and I'd be left with negative 4 equals negative 4, which is a true statement. So when that happens, that means it doesn't matter whatever you put in for x, you're always going to get a true statement. So infinite solutions is my answer. And that would look like x such that x is an element of the real number system. Okay? So keep that what if in mind, because I guarantee it's showing up in your try on your own, which is happening. Oh, try own your own. Try own your own. Well, go ahead and try it on your own. You should have one, no, or infinite solutions. And yeah, when you come back, I'll have the answers for you. Okay, put it on pause. Okay, welcome back. So, A, you should have gotten no solution. Nothing would work for A. Right? B, we got infinite solutions. Meaning, when I solve this all out, I get rid of the end, and I still have a true statement. Okay? And C, I actually have one solution, and that solution is x equals 0. Alright, remember, if you have any questions on this, please make sure you ask me in class. I'd be happy to help you. Regular algebra, that's all I have for you. That's your entire homework. Okay? And that was 7 minutes. So, new record. Honors, you still have a little bit more to do. Not much, but honors, please keep watching the video. Regular algebra, you're done. You can go ahead and stop the video. Regular algebra, if you want to watch the next part, though, you're more than welcome to. It can only help. So, alright, moving on to the next part, which is the honors topic, absolute value equations. So with absolute value equations, we need to remember that absolute value can only be positive. Okay? 3 steps in solving an absolute value equation. Absolute values, just really quick, have multiple answers, right? So if I said what is the absolute value of x, or the absolute value of x equals 3, there are 2 possibilities for x. It could be negative 3 or it could be positive 3. That's the same thing with this equation. So we kind of just split it up into 2 possibilities. So we isolate the variable using the inverse properties, and not actually the variable. That should really say the absolute value. So I'd like you to cross it out and write absolute value over that. So let's see if I can make it small enough to fit over it. Maybe? Not variable. We isolate the absolute value using the inverse properties, and I'll show you what it looks like. 2, we split the absolute value into 2 equations. One's going to be equal to the positive, one's going to be equal to the negative, and again, I'll show you how to do this so it'll make sense. And then we just solve both equations. So, most absolute values, again, I don't know why this stuff is showing, will have multiple answers. It's possible it has no solution, it's possible it has one solution. Majority of the time, though, it will have 2. Okay? Example 1, solve the following equation. So, step 1 is to isolate the absolute value. So we have to get this absolute value by itself. So I just use that as meg. So I'm going to undo the subtracting 8 by adding 8 to both sides first. Okay? Those 8s will cancel out, leaving me with 2 times the absolute value equals 28 plus 8 gives me 36. Next, I need to divide by 2, because I don't want to distribute that 2 to the absolute value. It's not parentheses. It's very different than parentheses. So I'm going to just divide by 2 on both sides. So now I have the absolute value equals 18. Okay? Now that I have this by itself, my absolute, whatever is inside the absolute value, that's going to either equal negative 18 or positive 18, because both of those, when I take the absolute value of it, will give me an 18. So this is how I've split it up. I take what's inside the absolute value, the negative 2x plus 3, I set it equal, weird, very odd. Set it equal to 18, because negative 2x plus 3 could equal 18, and the absolute value of 18 is 18, so it works. But I also set it equal to the negative, because it could also equal negative 18. So, because the absolute value of negative 18 could equal 18 as well. Okay? So, now that I have my two equations, I just go ahead and solve for x for both of them. So, let's start on this one. So, first thing I need to do is subtract 3 from both sides. Oh, fancy. It doesn't want to show. Well, subtract 3 from both sides. You can kind of see it. Okay? I'll end up getting 2x equals 15. Divide by negative 2 on both sides. X equals negative 15 halves. Okay? Or negative 7.5. That's one of the answers. The other one, I go ahead and subtract 3 from both sides. Ooh, you can't. Oh, yeah, you can see it. I get 2x equals negative 21. Divide by negative 2. I get x equals 21 halves, which is 10.5. So those are my two answers. Those are both answers for this equation. Okay? Let's try another example. Oh, didn't show the problem. Here we have negative 7 times the absolute value of x minus 14. So, first thing, I want to get this absolute value by itself. So I divide both sides by negative 7. And now I get the absolute value equals negative 5. Hold up. You guys seeing this? It's saying an absolute value is equal to a negative number. Can we ever do something to take an absolute value from me and get a negative number? No way. It's not possible. Okay? So when that happens, now that you have to be very, 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 very aware of. Okay? When that happens, there are no solutions. Not possible. Okay? And that would be our answer, is no solutions. And I know, it's tricky, isn't it? Alright, last two problems are for you, so go ahead. See that one I wrote, right? Try on your own. Show all your work. I want to see both equations when you do it, okay? So go ahead and solve these. When you come back, I'll have the answers. Pause it. Alright, so you came back. So for this first one, fortunately they were ugly answers, but they worked. Here I have x equals 31 over 5 and negative 11 over 5. Those are my two answers. Okay? B, I got an answer somewhere. Where'd it go? Oh, there it is. An answer of no solution. Okay? Because it probably, when I first subtracted the 7 from both sides and I divided by negative 4, I probably got an absolute value equal to a negative number. Hopefully you guys caught it. Okay? If you have any questions on this stuff, I will go over it in class, so make sure you have specific questions for me. Other than that, we're done, and it's 13:30. Woo! See you tomorrow.